Hey guys, today I'm going to teach you how to apply what we've learned about systems of equations to real life examples. By the end of this lesson, you'll be able to solve those real world problems with systems of equations. So go ahead and get out your binder, turn to the math section, and get ready to take some notes. So I actually have a really relevant real life example where recently I had to use systems of equations so I wouldn't get fired from my job. So here's what happened. We were working a ball game and we were selling these tickets at the door. Student tickets were $2, adult tickets were $3. We go through the night, we sell all these tickets, and then at the end of it, when we're supposed to fill out this sheet, where you tell how much money you made and how many tickets you sold, we were actually supposed to put on the sheet how many of each kind of ticket we sold. Now, we'd not kept track of that. I didn't keep track of how many student tickets I sold and how many adult tickets I sold. All that I had was the total number of tickets sold altogether, and I knew how much money we made in the night. I knew in total we sold 105 tickets. I didn't know how many student tickets, how many adult tickets, but I knew that the combined total was 105. I also knew we made $280. So this is not made up for this. This is a real thing that happened the other day that I actually had to use systems of equations to solve for. Because when I have these two things, student tickets and adult tickets, I actually have X and Y. X we can call student tickets and Y we can call adult tickets. And since I know some information, I can actually write an equation about what I know. So for example, I know that I sold a certain amount of student tickets. I just don't know how many I sold. That's why I'm using an X. And I know I sold some adult tickets. That's why it's a Y. I know altogether there were 105 tickets sold. So I can write this as an equation. This equation, X plus Y equals 105, is an equation for how many tickets I've sold. Now the other piece of information that I already knew was that it was $2 for every student ticket. So I can write that as $2 per X, $2 per student ticket. I also knew that it was $3 per adult ticket, 3Y. And if I add those together, I know we made a total of $280. So again, I don't know how much of each kind we sold, but on this form, it was like asking me to tell you how many of each kind did I sell. And I was thinking I was going to go get fired or go to jail for stealing money if I didn't put the exact right numbers down. So when I have these two equations here, I have a system of equations. And we've been learning how to solve the systems of equations. We've done it by graphing, by substitution, and by elimination. I'm going to show you two different ways that I could solve this system. But I chose elimination when I did this in real life. So when I looked at this, I saw that these were all lined up by their variable. So I was like, all right, well, they don't automatically cancel out. But if I multiply the top equation by -2, then the x's will cancel out. So I need to get the x's to be opposite. So this is a +2. If I made this one a -2, they would cancel. But since it's an equation, I have to do the same thing to every term on the inside. So I'm going to go ahead and just show you what my new equation looked like. There you go. So I just multiplied all these terms by -2. Now that I have them written like that, it's the same equation, but now it's canceling with the second one. So I can actually add those and solve by elimination. So those cancel. I add down. 3 plus -2 is just 1y equals -210 plus 280. And that gives me a +70. So I know that I sold 70 adult tickets. If I sold 70 adult tickets, I know that I sold 35 student tickets because 70 plus 35 gave me that 105. The other way I could solve this would have been by substitution. This was an extra step for me that I didn't want to take, so I did not solve it like this, but I'll just show you real quick. Since this first equation is not set equal to a y or an x, I can make it set equal to a y. If I do that, I just want to get y by itself, so I need to take away the x from both sides. So another way to write this top equation would be y equals 105 minus x. The number of adult tickets equals the number of total tickets minus the student tickets. And that should make sense to you. And then all you could do is plug in what y equals here as 105 minus x into the y in the second equation. Then you would solve it by substitution, and you'd get the same answer. So solving systems of equations helped me from getting fired. And I want to help you in the near future as well. So applying systems of equations means that we're going to look at some real-life examples of problems where you might want to use the system of equations to find missing values. So here's the steps to do that. Step 1, you want to define your two variables. So in the last one, I said x is student tickets, y is adult tickets. 2, you want to write your system of equations. So you need to write the equations that you have. 3 is going to be to solve it using either a graphing, substitution, or elimination method. And then 4, it's going to be find the answer to the question being asked. So let's go ahead and look at number 1. This is an example about Manny's Taco Shop. You can get an order of chips and 2 tacos for $9.25. the cost for 2 orders of chips and 5 tacos is $21.75. What's the cost of 1 order of chips? So the two things we're asking about here are chips and tacos. We want to know the cost of an order of chips and the cost of an order of tacos. So for the first box where it says define your variables, it means just write chips and tacos, and then next to each one, give one an X and give one a Y. It doesn't matter which one you say is X and Y, as long as you're consistent through the rest of the problem that you're solving. Here's what I mean by that. When I write my system of equations, I'm going to look in the problem and see what information is given to me. 1 order of chips and 2 tacos is $9.25. So when I say 1 order of chips, instead of saying 1 chip, I'm going to say 1X. So 1X plus 2Y, remember Y is tacos, equals $9.25. The second thing I'm given in the problem is that I know the cost of 2 orders of chips and 5 tacos. That is $21.75. So I wrote that as an equation. Instead of saying 2 things of chips, I'm going to say 2X, since X is chips. 2X plus 5Y equals $21.75. That's that total cost. So just having these 2 pieces of information, I have a system of equations. Now I have enough information to solve this. You can solve this system in this little box here, but what I would do, since it's going to take a little bit of work, I would go to a separate sheet of paper or a separate page, and you would solve it out over here. Now, when you solve a system of equations, you have 3 different methods. You have graphing, substitution, and elimination. I'm going to choose elimination for this one because I like elimination method, and I can see that the variables are lined up. You can choose graphing if you like the graph. If you like substitution, choose substitution. Any method will work, but I'm going to show you how to do elimination. So when I look at this, I know that elimination method means that I need one of my variables to cancel out with the variable in the other equation. So I don't have that automatically. I have a 2, a 5, and a 1 and a 2. I don't have that right away. So what I want to do is I want to manipulate one of the equations so that it does cancel out with the second one. So I'm going to manipulate this top one so that it cancels out with a 2. The thing that cancels out with a 2 would be a negative 2. So I'm going to multiply this whole equation by a negative 2. So I'm going to do this one step at a time and just watch me do this. It's almost like I'm distributing. So 2 times the 1x gives me a negative 2. That negative 2 also goes to this 2y. Negative 2 times a positive 2 equals negative 4. So I keep that negative 4y. And then lastly, that negative 2 has to go to this 925. So when I multiply negative 2 times 925, I get negative 18.5. And I made it 0.50 because this is supposed to be a dollar amount. So now that I've done that, I'm going to get rid of this negative 2 on the outside. This new equation that I just wrote is the exact same as the last one, except everything's double. So I have now 2 equations where the variable here cancels out. A negative 2 plus a 2 cancels. I want to do that so I can get rid of it and just have what the other one is. So negative 4 plus 5 is a positive 1. So I have 1y equals 325. Since I defined my variable y as tacos, I know that one thing of tacos is 325, excuse me. So now that I have the y, I also need to know what the chips are, since that's what the question's asking me for. What's the cost of an order of chips? When I solve a system of equations by elimination, I know that when I have one of the variables solved for, I need to plug it back into one of the equations to solve for the other one. I'm going to choose to plug the cost of the tacos into the first equation since it's smaller and a little easier. So this is that first equation, and I know that y equals 325. So all I did here is substitute in 325 in for the y in the equation. When I do that, I have an equation that I can simplify. 2 times 325 I can actually do. That's $6.50 or 6.5, 650. And I want to bring down this x plus. So x plus 650 equals 925. And then I'm solving a one-step equation. I need to get the x by itself, so I need to get rid of it plus 650. So I'm going to subtract 650. If I do it to one side, I have to do it to the other. And that is how I get x equals 275. So 275 being x is the cost of one thing of chips. I can write the solution to a system of equations in an x, y ordered pair format, but the question is asking, what's the cost of one order of chips? And since I just found that x is 275, I know that an order of chips costs $2.75. That's all I have to do for that question. Let's skip this one for now. If you want to try it by yourself, you're more than welcome to, and just ask me for the answer and I can check it for you. But let's look at number 3, where Kelly's basketball team made a total of 33 2-point and 3-point baskets in their game. If her team scored a total of 72 points, how many 2-point baskets did they make? This is important that we know these for stat sheets. And what if you mess this up or you forgot to write this down? If you know how to solve a system of equations, you can actually work this out. So take a second. I want you to write down everything that you know. Define your variables, write your system. Do everything you know so far, and then press play whenever you're ready to check. Okay, so I went through and I underlined the important information in this. There's 2-point and 3-point baskets. There was a total of 33 of those, and then the score is 72 points. So let me define my variables first. I'm going to have 2-point shots and 3-point shots. So I'm writing that in terms of X and Y. X is my 2-pointers, Y is my 3-pointers. My system of equations is that I have a combined total of X plus Y is 33 shots. There's 33 shots made. Now there was a total of 72 points. That's made up of the 2-point shots plus the 3-point shots. That gave us our final score of 72. And that's it from the problem. So you know this information from the problem. Now that you've got two systems of equations, you can actually solve it. Again, I would work this out on a separate sheet of paper, and then I would come back and put that answer in this box. Okay, so I have my two equations, so I have a system. I know that I can solve this by graphing, substitution, or elimination. I prefer elimination whenever I have the variables lined up like this. I just need to manipulate the second equation into an equation that can cancel with something in this. So either the 2's or the 3's. Go ahead and take a second, see if you can figure that out by yourself, and then press play whenever you're ready to check. All right, so I know that if I had a -2 here next to the X, then these would cancel. I knew if I had a -3 next to the Y's, these would cancel. I'm just going to choose one. I'm going to choose to cancel the X's. So I'm going to have to multiply this whole equation by -2. By doing that, I'm able to cancel this variable and then solve the system of equations. So -2 times 1x is -2. -2 times 1y is -2y. And then I need to also do this -2 times the 33, which is -66. Now that I've written it like that, I'm going to erase the times -2. Awesome. So when I solve by elimination, that means I'm just adding the equations. When I add them, these cancel. That's why I did that. That's why I manipulated it by multiplying that second one by -2 so I can cancel the x's. Then I can do 3 plus -2, which is just 1y, equals 72 minus 66. 72 minus 66 is 6. So I know that y equals 6. And since y is the number of 3-point baskets, I know that we made 6 3-pointers. So the next step when you solve a system is to solve for the other variable. I know the number of 3-pointers. I don't know the number of 2-pointers. So I need to put for what y equals 6 into one of the equations. I chose this one because it's pretty easy. The number of 3-pointers being 6 plus the number of 2-pointers gave me 33 shots in total. If you don't know that off the top of your head, you can always use inverse operations to solve this. Since it's a +6, you want to subtract 6, and x equals 27. That's the number of 2-point shots I made. That makes the solution to the system 27 and 6, 27 being the number of 2-pointers and 6 being the number of 3-pointers. The question was asking me how many 2-point baskets did I make, or Kelly's team, excuse me. So you just word that into a sentence and make sure you're answering the question. They made 27 2-point baskets. All right, guys, that's it. If you made it to the end of this video, please comment your favorite method of solving systems. Is it graphing, substitution, or elimination? And then you can also put in there if there's one you're having more trouble with, and I can help you with that. Today, we learned all about applying systems of equations to real-life examples. So now you should be able to solve those real-world problems with a system of equations. So go ahead and go back to the calendar, click any of those assignments you have left for the day. Let me know if you have any questions. Bye.